Okay, so if you have not noticed, the front page is about exponential growth, and the back page is about exponential decay. So growth, we're going to use a plus sign because it's increasing. Keywords for exponential growth, we can put it right here, are increasing, growth, let me see. See, increasing, 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 increasing. If it says anything about, what is it called? All of these say increasing. Okay, so we know that they're going to be growth. So what are these letters? A is the starting value or initial value. Start or initial. Okay? Just like we learned yesterday. R is the rate. Okay? And we were talking about cents yesterday, so cents and percents, same thing. And then T is the time. So the formula that we're going to be using for growth is A parentheses 1 plus R close parentheses to the power of T, or to the power of X. Okay? And so it's the same thing like we did yesterday because it's increasing from the dollar. That's why it has to be bigger than 1, and that's why you're adding it to that 1. So let's practice some. Problem number 1 says the original value, so that's the start, the initial value of an investment is $1,400. So in my formula, I'm going to start with $1,400. Start, write it down. And the value increased by 9%. How many cents is that? 9 cents. So 0.09, so it would be 1 plus 0.09, right? And then it says use exponential growth function to find the value of the investment after 25 years. So that's the time, so that would be up here to the power of 25. So you can put this whole thing in the calculator and it'll do it for you, just like that. Or you can go ahead and add them. That's 1.09. So this is the same thing as 1,400 parentheses 1.09 to the power of 25, just like we did yesterday, and that will give you an answer. So let's go put that in the calculator. 1,400 parentheses 1.09 close parentheses to the power of, remember we're using this symbol, to the power of 25. Enter. Okay? Now we're talking about an investment. We're talking about money. So is this good money? Or do we need to round somewhere? We need to round because money has cents, right? So it can only go to 0.31. So if you want to just say 0.30 or 0.31, that's fine with me. You don't need all the rest of those numbers. So go ahead and write that down on the paper. So tell me the number again. 12,072.31. So $12,000, $12,072.31. That's how much you would have in the bank after 25 years. Okay, so you're going to do the rest of this page just like that. I'm just going to show you real quick problem number 6, okay, because it's talking about years, and we're starting in 1985. So whenever they tell you that find the number of subscribers in 2008, you need to know the difference from 1985 to 2008. How many years did it, how many years passed from 1985 to 2008. So you can do 2008 minus 1985. How many years is that? 23 years. So really that's the time that I'm looking for. So let's see. It says in 1985, there were 285 cell phone subscribers in Mayville. That was a long time ago. That's when I was born, right? So that's why there wasn't that many people with cell phones. Do you think it increased big time from then to now? Yes, a lot. So we're going to say that we started with 285, and then I need parentheses. So then it says the number of subscribers increased. So I know it's going to be 1 plus something, right? It says it increased by 75% per year. That's a lot. So how do I write that in decimal? 0.75, right? And I need it to the power of 23 because it's 23 years later. So to the power of 23. Again, you don't have to add them if you don't want to, but that's 1.75. You can just put the whole thing like that in the calculator and it will give you an answer. So let's put that in the calculator, 285, parentheses 1 plus 0.75. See how I just put it in there just like that? Close parentheses to the power of, how many years? 23 years later. Enter. That's a big number of subscribers. And I don't need the 0.3, right? Because we're talking about subscribers. That's people. We don't have 0.3 people. So we're going to say 110,845,988 and write that down. That'll be your answer for problem number 6. On the back page. So I'm not writing this down. You guys are writing the number down. On the back page, it's the same exact thing, but we're doing decay, and decay is a minus because it's decreasing. So keywords that I see on this paper are decreasing, depreciating, depreciates. Those are keywords. That's how you know that it's going to be a minus. It says losses value, so it's decreasing, decreases. Those are keywords, decreasing. So anytime you see keywords like that, you should know that it's less than $1. We're subtracting, right? Just like yesterday, less than $1. So let's go up here. We're going to have the same exact thing. A is your starting or your initial value. Con lo que comienzas. R is the rate. That's the percent turned to a decimal. So percent to decimal. And then T is the time. So the formula is the same. We still start with A, parentheses, 1 minus R to the power of T. That's why we're always subtracting from 1, because it's less than the $1. All right, so for this one, the only one that I'm going to do with you is problem number 12, because that's talking about years again. So it says that the population of a town is decreasing at a rate of 2.25% per year. If the population in 2000, so this is when they started, was 28,000, let's write that down. 28,000 is what we start with. And it's decreasing, so I know it's 1 minus, right, something. I need to change that. I know that's a decimal already, guys, but it says percent, so we still have to move it to the left, So that decimal, let's put it up here. To the left, to the left. So what's my decimal going to be? 0.025. Okay? And I need the years. So we started in 2000. We ended in 2015. How many years later is that? 15 years later. So to the power of 15. So if you put that whole thing in the calculator, it will give you an answer. Okay? 28,000 parentheses 1 minus 0.025 close parentheses to the power of 15 years later, enter. Okay? Now again, what are we talking about? We're talking about population. So what is population? People, right? Population is people. So can I have 0.5792 people? No. So what am I rounding it to? No, I cannot have a decimal, guys. I cannot have a decimal because we're people. So it has to end right here. So it's 19,152 people. 19,152 people. Population is talking about people. So 19,152. So make sure that you read what it's talking about and round to the number that you think sounds best. Go ahead and finish the rest of the front and the back page.